Okay, in this section here, we're going to be going over finding an equation of the tangent line at a given point. All right, so we're going to be following these exact processes that we did up here, where we found the derivative and then the slope of the tangent line at the given point. But this time, we're going to go ahead and write the equation to that tangent line at that given point. All right, so let's go ahead and get started here, and it looks like I need to do some erasing. Erase the whiteboard from last time. I should have probably already looked at this. And yeah. All right, let's just get rid of all that. And I guess what I'm going to do is go ahead and bring up go ahead and bring up the graph and take a look at that. So let's do that. Take a look at a picture here. All right, so this is the graph of x squared. All right, and we're going to go ahead and find the equation, and we'll go ahead and we'll plot it of the tangent line at this point right here, which happens to be the point 1, 1. Okay, and this is x squared. So let's do that. What is going on here? We don't need, get rid of that. Some YouTube comment. What happened? All right. So I'm going to go a little bit fast on here because I'm going to assume that you already know how to find the derivative using the limit process. Sometimes we say the definition of the derivative. All right. And we're going to be at the point 1, 1. So that's a point on the graph, 1, 1. All right. Okay, so we found the derivative of x squared earlier using the limit process, and I'll let you do that, and remember that derivative should be 2x. Okay, 2x. And of course, we want to put f prime here, saying that this is the derivative. Okay, the derivative. Right. So we're trying to find the equation of a line that passes through the point 1, 1, okay, and has the slope. Now remember, we've got to find the slope. So let's go ahead and do that. Now remember the slope of the tangent line, right, at that point. Now we've done this. We did this in the previous section, so we're going to plug in our x coordinate. That would be this number that's right here in our ordered pair. And when we plug that in to the derivative, so 2 times 1 is what? Just 2. Okay, so we know that that's the slope of the tangent line. Okay, the slope of the tangent line. So remember, that's going to be m, which is the slope of a line, is equal to 2, and we have the point 1, 1. So we're going to use, there's a lot of formulas we could use. We'll just go ahead and use this one here. mx plus b. Okay, so this is m is your slope, and then this is where it crosses the y-axis at b, and so this is what we're going to need to find here. We're going to need to find b, and we're given the point 1, 1, which we'll plug into here. So we'll just go ahead and do this down here. So we have 1 is our y, our slope is 2, and our x, we'll go ahead and put that in parentheses, plus b. So in this equation right here, we're going to want to solve for, we got to solve for b. Okay, we got to solve for b. So that's, let's go ahead and rewrite this, simplify this down. And so as you can see here, what we'll want to do is, we'll go ahead and continue this over here. So we're going to go 1 minus 2. We're going to subtract 2 from both sides, right, to isolate b. So as you can see here, all I did was subtract 2 from this side and 2 from this side. And when we simplify this down, we end up with negative 1 is equal to b. So now we have our equation. Y is equal to m, which is 2, and then minus 1. You see that? So there's our equation. Let's go ahead and plot that on the graph. Okay, we're going to go ahead and plot that. And so that was 2x minus 1. See that right there? So as you can see here, this is the tangent line at the point 1, 1. So that was pretty easy. And of course you can see our b right here. This was negative 1. Okay, pretty simple there. So in this particular problem, I skipped some steps because we've already done this. We've done this, so I skipped this step here because we've already done this. We've done this twice. So up to this point, you should know how to find the derivative, okay, by the limit definition there, or the limit process, the definition of the derivative. And went ahead and found that slope. That was our m. Okay, we're given a point, and we went ahead and used the slope point form here. So there's a couple different ways we could have done this. We could have used a different form and found our b if we wanted to, but I'm just going to go ahead and use this, and hopefully you were able to follow this process. So it's pretty simple to do. Okay, so we'll do I don't know, we'll do about 4 more of these so you'll get the hang of it. All right.
One.
We're finding the equation of the tangent line at a given point. We'll call this function, let's give it a name. I always want to call them something different. We'll call this one L. How's that? L of x is equal to, let's do, I'm going to let you find the derivative using the definition. That's that going through the limit process. All right, how's that? X squared over 2 minus 3. Let's look at the graph of x squared over 2 minus 3. Let's take a look at that, see what that picture looks like. All right, so here's the graph of x squared. Actually, that's not the graph that I wrote. Let's do this. Okay. Here's the graph of x squared over 2 minus 3. And let me just pick a point. Yeah, that's not a good point. Let's pick something we're just dealing with integers here. What about this? This is a good one here. The point 0, negative 3. All right, so we want to find the equation to the tangent line, then we're going to graph it, of the tangent line that passes through the point 0, negative 3. All right, that passes through the point 0, negative 3. All right, so our point is 0, negative 3. And we're going to want to, this is our goal here. All right. So remember I said there was a couple ways. This is the point slope form. All right, and then you have, let me try to remember. I'm not going to use subscripts here. We'll just say y2 minus y1 is equal to, this is another way you can go about this. x2 minus x of 1. Yeah, that's for finding the slope. But you know what? Yeah, x of 2 minus x of 1. We're just going to go ahead and use the we're going to use the slope-intercept form. The slope, I may have said the point slope form. This is the slope. The slope is m, and then your intercept. Yeah, your intercept form. Okay, we'll use that. We'll work an example maybe in the next one using the point slope form. All right. So we want to find. So we have both our y and our x, but what we need to find is our m and our b. Now remember, finding your m, that's the slope. Okay, and to find the slope, we need to find the derivative L prime of x, and I'm going to let you figure this out on your own. So you're basically being tested here, and I'm going to look at it and go, oh, well, that's just x. And see, there's a pattern that I'm not going to tell you. We'll talk about it in the next section, but that you can just look at that and know what it is without having to go through that whole limit process. And then the derivative of a constant is 0. Okay, so I'll let you work that out. All right, and now let's go ahead and find that slope. So L prime of 0, we're plugging in. All right, plugging in our x value, 0. And when we plug 0 in, well, we just get 0 out. So the slope, we can see here, m is equal to 0. And of course, we could see that just by looking at the graph that m was going to be equal to 0 because our tangent line was a horizontal line. All right. So the next thing we want to do is want to go ahead and plug in our plug in what we have into our equation here. So we're going to plug 0, -3, and m in for the slope. So -3 goes here for where the y is located, and then 0, and that's our slope. And of course 0 is also our x, and then b, well, we don't know what b is, so we'll just say b. Okay, now capital B, that's the same kind of b. So as you can see in this, that -3 is going to end up equaling b. Okay, so let's go ahead and write that up here. So b is equal to -3. All right, b is equal to -3 because this just ends up being 0 here. Okay, so now we have it. You know what? Let's just write it right up here next to it. Okay, so y is equal to, our m is 0, and of course we'll be able to simplify this. And our x and our b is -3. And of course we can simplify this now. 0 times any number is still going to be 0, so this simplifies down to y is equal to -3. Y is equal to -3, so that's going to be the equation of the tangent line that passes through the point 0, -3. Okay, so let's bring our graph up here, and let's go ahead and graph this. It's -3. And y isn't. Alright. For whatever reason, I gotta say y is equal to -3. Oh, there it is. Okay, finally popped up. So the green line here is our tangent line, and you can see it's tangent at the point 0, -3, which is nothing more than just a horizontal line. Okay. All right. Okay, well, let's look at another one.
One.
We are looking at at finding the equation of a tangent line that passes through a given point. We'll call our function O. How's that? Got to call it something. Is equal to, we need to actually write this in. Bring up an equation box. Let's see, what could we call this? Let me think here something. Okay, all right. So remember, you're going to be using the limit process to finding the derivative. I did that in the last two sections, so basically it's test time now for you. Let's look at the point. Well, we'll do something easy on this one. Yeah, let's look at the point 0, 0. And we want to find the equation y is equal to mx plus b. Okay, this is the goal. We want to find this because this is going to be the equation of the tangent line. So this is the goal right here. But the first thing we're going to need to do is find the derivative, which we'll call O prime. Go ahead and write it back in that format there. O prime, and this is the part that you're going to have to do on your own, right? If you followed the last two sections. So the derivative is 4x plus 1. Now you must be asking, how in the world are you doing that in your head real quick? Because, well, there's a shortcut pattern. Believe it or not, we got a shortcut to all that, but you'll have to use the limit process first. All right, so now that we found the derivative, let's go ahead and find m. I'll just write that out over here. So O prime of 0, right? O prime of 0, we're plugging in the x coordinate, and when we plug that in, we get 4 times 0 plus 1. And of course, that's going to simplify down to 1. Okay, simplify down to 1. So we have m is equal to, our slope is going to be 1. Okay, so now what we want to do is want to go ahead, plug in everything we got so we can solve for b. Now, I was going to mention it in the previous video, so they call this the slope, b is the intercept, is known as the slope-intercept form. However, there's another form that we use. I could use a subscript there, or I could use a 1. I don't know, will it let me do that? No, I was thinking there was a shortcut way of doing that. I'm just going to say y of 1 here. So this is called the point slope form. And in the point slope form, okay, instead of solving for b in this problem, what we're going to do is just solve for y, where we plug in our y of 1, plug in our x of 1, plug in our x, and then we're given our m already. Okay, we'll go ahead and do that down here. I guess we'll just use this one. I think I said I was going to. Okay, so y is equal to, well, y minus, getting ahead of myself here. So the y1, this is your x of 1, and this is your y of 1 here, and they're both 0. So. And of course our slope is 1. Okay, we'll start at parentheses, and then I'm just going to write in our x because we're not substituting anything in for that, but my x of 1, which would be this coordinate here, is also 0. Now what we'll want to do in this equation here is solve for, we want to solve for y. Okay, so x minus 0 is just x, so we end up with just 1x, and of course y minus 0 is just y, is equal to 1x, but we don't write 1x, we just leave that off. He's invisible. If he's a 1, he becomes invisible. So the equation of the tangent line, okay, passes through this point right here is y is equal to x. Y is equal to x. So let's take a look at the graph. I don't think I was going to bring up the graph. I never did. I can't remember if I did or not. Okay, so here's the graph of 2x squared plus x. I need to look at something here real quick. Okay. Let's go ahead and graph this. All right, they're going to give us an orange one this time. So here's the point 0, 0, okay, on the graph 2x squared plus x, and you can see the orange line here is the tangent line. This is the tangent line that passes through the point 0, 0, right, of the curve 2x squared plus x. Have we talked about the secant line? I don't think we never did. Maybe we'll talk about it in the next section. But all right, well, that's pretty simple. This time we used the point, and the point was x of 1, y of 1, and the slope. So we used the point slope form to find the equation of the tangent line instead of using the slope intercept form. And a lot of people like to use this one here instead of this one. Okay. We're finding the equation of the tangent line that passes through a given point on the curve. Say that that line is tangent to the curve. Let's call it O again, and maybe you'll start seeing a pattern. And what pattern I'm talking about is, well, it's a secret. O of x is equal to negative, let me think here. Actually, I got it written down here. Negative x squared plus x plus 4. I don't think we've done that one yet. And it's going to be passing through the point. We always do something simple because we're just trying to get the concept through here. How about the point 0, 4? Okay. Passes through the point 0, 4. So what I'm doing here is I'm just taking 0 and plugging it in. 0, 0. And O sub 0 is 4. Right? So the goal is that we want to find the equation to the tangent line. In other words, we want to find that right there. But the first thing we're going to have to do is we're going to have to find the derivative. Okay, because we got to find that m. In order to find m, we're going to need to find the derivative. All right. What's going on here? My computer's locked up. Great. Okay. I don't know what happened. There we go. So we're going to find O prime of x. Wrong x. O prime of x is equal to, and of course it's negative 2x plus 1, and I can just look at that and tell what it is. So maybe you'll see a pattern, not have to use that crazy limit thing. And I don't know why it's doing that. And there's oh man, what a nuisance that's going to be. What does it cause that? Spell check. Let's see, tools. How do we turn that off? Let's see, show spelling suggestions. You know, I've never had that problem before. I don't know. Huh. It's kind of a, I don't know. Let's just deal with it, I guess. It's saying there's a spelling problem. All right. Taking up my valuable time here. Now, I think we used well, that's the goal right there, but let's use, well, I just noticed something. We need to find what M is, and I could actually say M is equal to, this may not be appropriate, but we're going to do it anyway. All right, plugging 0 into O prime, and that's going to be equal to -2 times 0 plus 1, right? Which is actually equal to 1. Okay, so we know that our slope is 1. M is equal to 1. We'll just go ahead and rewrite it right here. How's that? And we're going to go ahead and plug it into that point slope form. So we said the slope was 1, x minus x of 1. This is what we're plugging it into here. I think I was just going to go ahead and just write the form out and then. Okay, so we have y minus, so this is our y of 1, which we're calling 4, is equal to our slope, which was 1, x minus, and of course that is our x of 1, which happens to be 0. All right, and we want to go ahead and solve for y in this problem, so we're going to have y is, I guess I won't skip any steps here since we're doing this stuff for the first time, let's say. And so we're adding 4. We got to get rid of this 4 right here. So we're adding 4 to both sides. All right. X minus 0. And we're adding 4 to both sides. You see that? Okay, so that's just going to end up being y is equal to, and this 1 multiplied across is not going to do anything, and that's just x. So that's going to be x plus 4. So as you can see here, this is the equation right here of the tangent line. That was the goal, to find that. Y is equal to x plus 4. Let's go to the graph. All right, so here's our graph, negative x squared plus x plus 4. And this was the point right here that we were 0, 4, that we're going to find the tangent line that passes through that point. And I've already forgotten what it is. Y is equal to x plus 4. Okay. Y is equal to x plus 4. All right, so you can see this is the tangent line that we were looking for, the equation to this line that passes through the point 0, 4. Pretty simple. Pretty darn simple, right? Okay. All right, so we got one more problem that, well, what's going on now? Oh, hey, how's it going? There I am, where camera's down here. I didn't mean to click on that. I guess I was supposed to. Anyway. All right, we got one more problem. I need to figure out why I did that. And then we're going to be moving on to the shortcut methods of actually finding the derivative of these functions. All
right. 1.
All right, in this problem here, we're going to be finding the equation of the tangent line that passes through a given point on the curve. We'll call our function r. And we will look down when we say this. R of x is equal to, let's see here, let me think, x minus 2. Now remember, you'll have to find the derivative using that limit process. And that's something I covered in the last two sections. We're going to need to find r prime. If you followed me on the last 4 problems, then you should know where we're going with this. So we'll need to find r prime, but the goal here, remember, is to find y is equal to mx plus b. And I've been using, to get to that point, we've been doing y minus the point slope form to find that equation. Y minus y1, I've just been writing it like this, and x minus x of 1. Okay, so the first thing we want to do is first correct that mistake. First thing we want to do is we're going to find m, and then we're going to plug in our point, which I haven't even written up there yet. We're going to plug our point in and then solve for y in this problem. And the point we're going to plug in is, let's see, let me think here. How about 3? If I plug 3 in, what do we get? We get 3 minus 2 is 1. 1 minus 3 is negative 2. Oh. Alright, let's take a look at the graph here, see what we got. So at 3, negative 2, let's see what we got here. So here's the graph, and 3, okay, there's 3. Right there. Okay, so we're going to be looking for the tangent line that passes through that point, 3, negative 2. I wonder if I can write that in. Let's try this, see if this thing will identify a point. Whoops. 3, negative 2. I've never used this graphing calculator. Yeah, there's the point right there. Okay, so we want to find that tangent line. So as you can see here that the slope we do know is going to be positive, right? The slope of the tangent line is going to be positive. So if our answer comes up to being negative, we know we've done something wrong. We know we've done something wrong. All right. Okay, so I'm going to look at this and tell what the derivative is going to be. Okay, I think I got it. 2x. Now let's get in the box there. 2x. I think 2x minus 4 is the derivative. Pretty sure. Yeah. And I'll let you use the limit process figuring that out, which I went over in the last two sections. We want to plug in our x coordinate. We get 2 times 3 and minus 4. Right, so we want to go ahead and simplify that. We're going to have 6 minus 4 is 2. Okay, so it looks to me like that the slope m, I think we're using a small m is equal to 2. Okay, well, we got everything we need now. So let's go down here, or why don't we just do this? Y minus y1. So that would be our negative 2. And notice I'm putting parentheses around this. Okay. The reason for that is because of this minus sign out here. Right. Our slope is 2. We have x minus 3. And now what we're going to want to do here is we're going to want to simplify this thing down. So we want to solve for y. We've got a minus out here, a negative, so that's going to make that a positive 2. And I'm going to go ahead and distribute this 2 across here. So we have 2x minus, and the 2 times the minus 3 here is going to make that a minus 6. All right. And of course, what we'll want to do now is we're going to want to add 2 to both sides. Whoops. Scratch that. Subtract 2 from both sides. So we got to get rid of this 2. We're trying to isolate this y. So we subtract 2 from both sides. Right, and then we're going to go ahead and simplify that. Come up on the screen a little bit. Alright, so we end up with y is equal to, alright, so that's going to be 0. We got negative 6, negative 2, that's 6, 7, 8. So we have 2x minus 8. Alright, see that? 2x minus 8. Okay. Now, you should be able to take this point, take this x value, and plug it into here, and your y better be negative 2. Okay, because remember, this is a point on the graph, okay, and that tangent line is passing through that point. So they both share, what they have in common is this point right here. If I plugged in 3, I get 6, and 6 minus 8 is negative 2. All right, let's go back to the graph, 2x minus 8. Okay, 2x minus 8. Ah, look at that. There it is. All right, so this time it's a black line. Never know what it's going to be. And it's the line that's tangent to this red line, which is our curve, passing through the point 3, negative 2. All right, passing through the point 3, negative 2. Okay, so we basically swept the floor with that one. All right, so that's going to end. I think I'm trying to work about 5 problems for each section. And now what we're going to be doing is we're going to be getting into basically the shortcut method of finding the derivative, okay, of the function. And we'll start with the constant rule. This will be in the next section. All right. See, learning calculus is pretty easy, let me tell you. It really is. All right, I'll see you in the next section on the basic differentiation rules.